And welcome back. As we go ahead and dive right into our next lesson, we're going to look at short circuit versus complete evaluation of Boolean expressions. And this is something we're actually going to encounter quite a lot when we start looking at compound Boolean expressions and how that can actually come in handy for helping us potentially avoid some issues. So let's take a moment to think back about our truth tables and how that was handled with our Boolean evaluation, particularly when we look at and or. If you remember in that concept with and or truth tables, and pretty much said if we have something that is false, well then of course the whole table is going to be false unless you have two truths, and with a or it's always going to be true unless you have two falses. So the way this works is that Java is going to utilize shortcuts when it evaluates Boolean expressions because it knows those two things. It says, oh, if this is an and expression and I know that I have a true, well, I'm going to have to check to see if I have a true for my second value. But if I have an and, well, then I don't need to check anything more because I know if it's an and it's a false for that first value, well, if it's false, it's going to be false for the second value. Or it could be true, it doesn't matter because the end result, the end evaluation will be false. And let's look at that here. All right, and the reason why we only need to look at part of that is because when we look at those certain values, we only have to evaluate part of the expression to know what the end result is going to be. And this process of looking only at part of an expression is what's known as a short circuit evaluation. So if we look at an example here, I have savings is greater than or equal to 0 and depends is greater than 1. If savings would be negative in this expression, well, we could say, well, that part of our expression is false. And if we remember looking at the truth tables, as I already mentioned, if we have an and expression, which we do here, and one of those two parts is false, well, then the whole expression can be treated as false. In this case, Java is going to look at that first part because it works left to right, and it's going to say, oh, I come across that first part of the and expression, I see that is false. So rather than going and evaluating that second part of the expression and trying to determine a value for it, it's simply going to skip over that because it already knows the first value is false and is automatically going to determine the value, which in this case would be false. So when we start looking at evaluations of and or, Java will shortcut an and expression if part of the statement is false, particularly when we're looking at that first part. If it's looking at a or expression, it's going to do the exact same thing, but if that first part is true. If we look at another example here, we have if kids is not equal to 0 and pieces divided by kids is greater than or equal to 2. So now print line, each child may have 2 pieces. In this expression, the number of kids is 0. So if we say this is 0, all right, then this would be false, which means Java could then short circuit this evaluation. You can say this whole expression is false because we have an and here. So this part right here, false. Remember our truth table, we have false, and anything else over here doesn't matter because we already know we have one false. If this was a true, then Java would have to go and evaluate this second part here. Additionally, one of the other things this does by using short circuit evaluation, we can kind of exploit this to a degree to prevent a runtime error divided by 0. Because what's if we had 0 kids? Well, this would be dividing by 0. And that's going to give us a divide by 0 error. Now, the other side of the coin is complete evaluation. This is when you want Java to look at a full expression. And we can ask Java to do a complete evaluation wherein the program evaluates the expressions first and then checks to see the truth table. However, for our purposes, we're always going to use compound expressions using and or to obtain short circuit evaluation, as it is very helpful to avoid the issues like runtime errors, like we mentioned, like divide by 0. Now I went ahead and set up a quick program here, and I have a couple variables in here. So I have num1 is 3, num2 is 0, and num3 is minus 3. And if you look here, I have a quick expression. This is a or example here. And so this is a or short circuit. So this is an or, and I'm just going to make a quick note here that this is an and, because you notice we have an or and an and. And here we said if number 1 is greater than number 2, or number 1 divided by number 2 is greater than 1. Now, I purposely set this up this way because if you look at what number 2 is set to 0. And this, of course, would trigger a divide by 0 exception. And so this says, okay, we have an or, which means this part right here needs to be true. All right, so if we say, okay, this is true, and what does it matter if this is over here? Because number 1 is 3, number 2 is 0. So as long as it sees this is true, Java's actually just going to skip right over this part here. All right. And if we look at this part, we got number 1 is less than number 2. All right. So this is doing an and. So this is right here. It's going to come back as false. And then, of course, we have the exact same expression over here. Now, notice we also have a not in here because if we don't put this, of course, would evaluate as false, and so we wouldn't get any output. So just to get this output, just to test this, we did put this not in here to invert that answer. And, of course, if I run this, we get 2 successful short circuits. Now, just to show you what would happen if I have even just this expression by itself. So I'm just going to make a quick if statement here. I'm just going to actually say bad expression. And let's do an if. And I'm just going to add just a print line statement just so we can see it. And notice it will compile fine. Like you notice they're not getting any errors here. However, if I go to try to run this code, let's just go ahead and run. We do get our first 2 outputs, which we know work. But then, of course, you can see we get this divide by 0 error. And that shows you that right here in both of these expressions, Java is skipping this back end because it's saying, oh, I don't need to evaluate that part. Even though by itself, this expression, this num1 divided by num2, because the num2 is 0, throws this divide by 0 error. This doesn't actually get evaluated up here because, again, it's using short circuit evaluation rather than evaluating the complete expression. Now, we could, of course, try to trigger this and just to show you a complete bad expression. So let me just grab this and here. And what if let's just go ahead and leave this as is, but let's just say we flip this. Let's just say, just make that gray there and just see what happens here. All right, notice we're still getting this divide by 0 expression here, so I need to take this out for a minute here. And notice now, if I try to do this one, notice we get a divide by 0 error. All right, and why is that? Well, if we look, we have num1 is greater than num2, so that is a true expression here. And because that's true, and this is an and, it has to evaluate this second part here. So this is I'm just going to put the other expression here. I'm going to say this is a bad and expression. All right, so we would not want to use a and expression that is going to give us a bad short circuit evaluation. All right, so this is a bad evaluation because, again, this one is going to throw that divide by 0 error. And that's a very common one that you might run into, especially if you're doing anything numeric. What we want to do instead is try to set up our expressions in a way that we can use short circuit to avoid these errors here, particularly like this divide by 0 if you're going to do anything numeric.